So for those who don't know me, I'm Ángel del Pino, and for my PhD thesis, I'm working on the electric model and emission analysis of a bare photovoltaic tether, and I'm supervised as well by Gonzalo Sánchez Arriaga. For this presentation, I will first speak about the context of BPTs, and then I will move to its mathematical model that I will move very rapidly through it, so you can ask me later at the questions or at the coffee breaks. And then I will also speak about the hardware emulator that we are working on for an electrodynamic tether system. So to better understand where is my thesis topic located, we first need to know what are electrodynamic tethers. That electrodynamic tethers are long conductors flying in space, that, as you can see here, that they are joining two spacecraft, and they are used to generate thrust without the requirement of any propellant. Across the different years, different systems have been proposed to enhance and to make the system more efficient. This includes passive and active elements such as bare tethers, lower function, and now we are suggesting bare photovoltaic tethers to enhance this performance, and this is done by adding some extra energy to the system, and we can enhance the performance and produce a higher force. In our case, it's used to deorbit a spacecraft. And in this picture here, you can see what are these photovoltaic cells, that they are placed on top of the electrodynamic tether itself. So, as I was saying before, we have started first constructing the mathematical model, and once that is verified, we have built the hardware emulator, and we will use this tether emulator with real flight avionics. So we will validate flying avionics with these electrodynamic tethers. As I said before, I will move very rapidly through the mathematical model, but our tether consists on a standard tether with the PV cells on top, and we are modeling it as this extra power included in parallel to the circuit. What is important from the mathematical model is that since we are using a different segment on the tether, we need to modify the equation that govern the tether. So in purple you can see the novelties that we have introduced on it, and the same one, we have followed the same dimensionless analysis typically done in tether analysis, plus new implementation. And this all leads into a new formalism, and it's important to say that the standard tethers can be derived from this model if we set the photovoltaic segment to 0 and if we fix the physical properties of the system. Once that we have these equations are nonlinear, so we have to solve them. We first build a numerical model, and it's been checked, and it's also integrated into BETSMA, which is a high fidelity tether emulator software developed by Gonzalo. So these are the results, and with the photovoltaic tethers we have discovered a new operational regime that is in the purple square, as well as all these different operational regimes that they differ for standard bare tethers. We would only focus on this first part, but for the BPTs, we need to include this different section that somehow complicate the mathematical modeling. Now, if we move to the hardware emulator, we have built this electric ground support equipment in two main parts, I might say. One is the the data from the sensors of the spacecraft, and the other one is the electrodynamic tether itself. So in this picture here on top, you can see how this microprocessor board is emulating a simulated data from a spacecraft, and this data is embedded into the real onboard computer that will be on flight. And then afterwards, we have included the electrodynamic tether ground support equipment, emulating as well the electric behavior of the tether. So focusing now on the electrodynamic tether, we have first construct how the system is connected. It consists on 3 or 4 main elements: the electrodynamic tether, the hollow cathode, the plasma, okay, and the electric power module. That is the system that is inside of the satellite avionics to control that the current and voltage produced by the tether it's okay for our requirements. So the mathematical model has been developed. We have run different parametric analysis, and the most relevant result that we have found is that we need to include at least 5 watts to produce an effective thrust for this mission, the ETPAC project. And with that known, we have modeled the electric power module, and we have developed a hardware-in-the-loop setup to test that first, that the electrodynamic tether module is working itself, and then using real flight avionics, we will validate as well this box. So we have modeled the electrodynamic tethers with one programmable power supply and with one resistor, and the electric power module with a fixed power supply and a resistor, and the hollow cathode is simulated with a combination of Zener diodes that emulate the behavior of a real hollow cathode provided by a partner university, the University of Dresden. And regarding the results, we have done some power dissipation and power injection test, because as you saw here, this electric power module supply can either inject power with the power supply or dissipate it with the variable resistor. Here I'm showing the results for the power injection test, and as you can see, the results are matching the expected results, and a similar conclusion can be extracted with the power dissipation test. So for the future, we would like to include the real electric power module supply that is currently being developed at Zener Aerospatial, and also we would like to improve the hollow cathode curve. This one is the real one is the red, and we are using this green curve, so we expect to improve this as well. And regarding the achievements of the PhD thesis, the mathematical model was first presented on a conference, and then we further improved it and include new section, and it was published on Acta Astronautica. And regarding the hardware emulator part, it has been accepted for a presentation in the next week in the Tether in Space Congress in Toronto, and we hope to include all the results of the test with the flight avionics and submit it to Acta Astronautica as well. And yeah, also we will include some mission analysis and theoretical result simulation at the EIC Congress, and I will further study this on a research stay in Padova this summer. And yeah, that's everything from my side.